Hey, so I'm going to make this quick video trying to explain combination circuits. I'm going to start with resistors and then kind of move and incorporate how an inductor or a capacitor might work in a combination circuit. So when I say combination circuit, what I mean is that we have both series and parallel branches. Um, Now notice that flowing across R1, we don't have any choice. We have to flow across R1 with our voltage sources right here, and we have to go through R1. But once we get to this point, we get two choices. We can split left or right. If we split right, we get to go through R4. If we split left, we have to go through R2 and R3. So once that split is made, you're on a series path, even though these two are parallel to each other. For example, um, even though they're parallel, you can't go through R2 and then go through R4. Once you go through R2, you have to go through R3. And so the idea of the voltage being the same across the parallel circuit comes from the idea that, let's say I have point A here and point B here. Now, if anybody's goofed around with a multimeter or a voltmeter, if you were to put one lead here and one lead there, you would measure one voltage, correct? Because your voltmeter can't measure more than one voltage. So a consequence of this is if the voltage from here to here is one value, that means that the voltage across these two resistors is one value, and the voltage across this resistor is one value as well. Now, that doesn't mean that the voltage across R2 is the same as it is across R3, because once we break into a parallel circuit, we now have a series circuit. And so that's why they call it a combination, is because even within a parallel circuit, you can have small series circuits like this, or even large series circuits. But the idea of a series circuit is that when you go across a resistor, you lose some potential. And we call that voltage, so we're going to lose some voltage here. We call that a voltage drop. I would call it V sub D1 because it's the voltage drop across R1. Now once we split here, even though the voltage from A to B is the same, there will be a voltage drop across R2 and a voltage drop across R3. There will also be a voltage drop across R4, V sub D4. And the thing about a parallel circuit that's special is if the voltage from here to here is measured the same, that means that the voltage drop 2 plus voltage drop 3 must equal voltage drop 4. So in other words, when electricity goes through a series circuit, it must drop the same amount of potential on either track by the time it gets to this second point. And so that's useful. We could write an equation. The voltage drop across R4 equals the voltage drop across R2 plus the voltage drop across R3. So just because you're in a parallel circuit does not mean there's no longer a voltage drop. It just means that the voltage drop is going to be relevant to the series circuit that is within a parallel circuit. So this is a series circuit within a parallel circuit. So that's with resistors. Let's throw in a capacitor and see what difference it makes. So of course, adding capacitors in series is similar to adding resistance in parallel. And adding resistors in parallel is the same as adding capacitors in series. Now the reason why that is because let's say I take two capacitors and put them side by side in a parallel circuit. Now capacitance is directly proportional to the area of a capacitor, right? So we could replace these two capacitors with one bigger capacitor. And that one bigger capacitor would actually have the same area as these two individual capacitors added to each other. And so because area is directly proportional to capacitance, if we have C1 and C2, our equivalent capacitor is going to have to be C1 plus C2, because the area of this equivalent capacitor is the area of C2 plus the area of C1. So that's where that whole mix-up goes. The difference with resistors is if we have two resistors in series, remember resistors are going to resist flow, and so and one rule of current is that it takes the path of least resistance. So when you have a resistor here and a resistor there are more paths to go down, and more current will flow down the easier path. And so that's why when you add resistors in parallel, you actually kind of get less of a resistor than you would have had with just even one of these resistors, because there's two paths now. Whereas if you make the current go through both resistors, you're going to effectively create a resistor that is equivalent to R1 plus R2. So the reason why these two additions are different is because they're fundamentally different concepts. One's resisting, the other's storing. So let's throw a capacitor inside of our circuit here. We'll call it C1. I'm not even going to give it a value. So let's say there's a switch here, and the switch is open. The second I close the switch, okay, current is going to flow through R1. It's going to split at A. Some of the current's going to go through R2 and R3 to ground, and some of the current's going to start filling up C1. Now with a capacitor, think of it like a reservoir. Okay, so like for example, let's say that you have a river and it splits. And then this part of the river goes into a reservoir. And that reservoir has a certain depth. It can hold a certain amount of water. But this just keeps going to the ocean. Okay, so this is going to the ocean, and this is going to the reservoir. Now, at first, when we open the dam and we let water flow through, the water will split here because it senses that there's just about less, there's least resistances both ways. We'll just try both. But as this reservoir fills up with water, at some point it's going to not allow any more flow. And then all the flow is going to go on the path to the ocean. That's what a capacitor is like. When you close the circuit, when you close the switch, electricity will fill up on the capacitor until the capacitor won't allow flow anymore. And then at that point, all the current will be forced to go through R2 and R3. Now, if you measure the voltage from A to B, you'll still have one value, which means that the voltage across C1 is equal to the voltage drop 2 plus the voltage drop 3. So that fundamental idea that if you probe across a parallel circuit, you're going to get one value. That's where the whole idea of voltage doesn't change in parallel, whereas it does change in series. The only reason I say that is because you can only have one value measuring from the split to the rejoining of two series circuits, creating a parallel circuit. So think about a capacitor kind of like a reservoir. I think that'll help quite a bit. And of course, going back to adding capacitors, if we had two reservoirs, all we would be doing we would be increasing the time that water can flow into the reservoirs before it fills up and everything is diverted down the resistor path. So hopefully that was helpful, and let me know if there's anything I didn't hit. Thanks. Bye.